In section 3, we're going to continue looking at parallelograms. And now we're going to test whether something is a parallelogram or not. So we're going to recognize the conditions to see if a quadrilateral is a parallelogram, and then we'll prove whether a set of points forms a parallelogram in a coordinate plane. A lot of these tests are the same properties that we looked at in section 2. So if you can show me that both pairs of opposite sides are congruent, then you know that it is a parallelogram. The next one is saying if you can show that opposite angles are congruent, then it's a parallelogram. If you can show me that the diagonals bisect each other, then it is a parallelogram. This one is slightly different than what we looked at in section 2, but it's pretty similar in the fact that if you can show that one pair, notice that this is the only time that you can talk about one pair, but one pair of opposite sides is both congruent and parallel, then you know it is a parallelogram. So we're going to try this over here. I've got 3 examples. Determine whether the quadrilateral is a parallelogram and then justify your answer. The justification, I want to know which property are we talking about over here. Okay, so looking at the first one. Go off of specifically what they tell you. So in this case, JH is 14 and FG is 14. We know one pair of opposite sides is congruent. If I wanted to know, I wouldn't be able to use the property that states both pairs of opposite sides are congruent because it doesn't tell me anything about FJ and GJ or GH. Therefore, I need to use the angle measures of 180. And since they add up to 180 degrees, we know they're consecutive interiors, which makes this side parallel to this side. Therefore, we do know, yes, it's a parallelogram. And we know it's a parallelogram because of this bottom property down here, 6.12. If we can show one pair of opposite sides is congruent and parallel, then it's a parallelogram, which is exactly what we did. Congruent and parallel. The next one, this one shows us that this side is congruent to this side, and this one's congruent to this side. So yes, it's a parallelogram. Parallelogram. We're looking for the property that states both sets of opposite sides are congruent, and that would be this one up here at the top, 6.9. Both pairs of opposite sides are congruent. It is a parallelogram. The last one, 1B. I know that one set of opposite angles is congruent, and I know that one set of opposite sides is congruent, but that is not enough. I would either need to know both sets of opposite sides are congruent, or both sets of opposite angles are congruent. So no, we don't know whether this is a parallelogram or not.